Hey guys, so today we're starting something slightly new, still part of the same unit, but we're going to be learning about the properties of circles starting today. It begins on page 237 of your book, but we'll end up extending that with a couple exercises. So first we need to review some vocabulary. So here's my circle and I've already made some changes to the diagram. So the first term we need to know is circumference. This is something you've seen before. It's the measurement of the distance around the outside of the circle. Then we need to know the center because this forms the basis of definitions for the other parts. If a line passes through the center from one side to the other, that is our diameter. But if only goes from the outside to the center, then that is our radius. Now, if I have this black brown line here, it doesn't go the entire circumference, but just part of it, that is known as an arc, and the space inside of it is known as the sector. Now, if we have a line like this pink one here that does not pass through the center, it is known as a chord, and then the blue shaded in region is called the segment, okay? So the first part of today's lesson, we're going to be looking at the angle in a semicircle. So just in case you're not aware, the semicircle is just another word for the half circle. Okay, so if we have a line that passes through our center, it's a diameter, of course. If I have, let's consider this point A and this point B. If I have a third point C and I put it anywhere along this arc, anywhere along that, if I connect it to both points A and B, that tells me that this angle here is going to be a right angle. If I were to put C over here, let's call this point D, and then I connected that to A and this to B, that this angle also is going to be a right angle. So let's take a look at the implications, right? So let's do number 1 together here. So here I have a line that passes through, the center O, and then my third point here is going to be somewhere along the arc. So that tells me this is a right angle. So I know that's 90. 90 plus 30 plus x equals 180. So of course we know that x equals 60 here. That was kind of an easy example just to illustrate exactly what it is that we're doing. So let's take one that's a little bit more difficult. So here is number 6 from that same exercise. So here we're going to have to use a little bit more of our understanding of triangles in order to solve it. So first of all, I want to know what this, goodness gracious, I want to know what this angle x equals. So I'm going to look for my triangles. I can see this triangle here. It is isosceles because this side and this side are equal. So that tells me this angle and this angle are going to be equal to one another. Okay, well, looking at that here, the knowledge that I just learned is that this diameter passes through the center and the triangle connects the 3 points, one on either end of my diameter, and then a third point somewhere on the arc. So what that tells me is that this is a right angle. Okay, so that's going to be 90 here. And if the other two sides on my right angle are equal to one another, that tells me that these two angles are going to be equal to one another. So I know that each one of these is 45 degrees. And now that I look at it, let me think. Aha, so I also know that because this is a straight line, that the blue and this purple angle, when I add them together, it has to equal 180. So let's call that y. We're looking for whatever this value y is. So y plus 45 is going to equal is going to equal 180. And so y here is going to equal 135. Okay, so we'll call this x because this x and this x are equal. 135 plus 2x is going to equal 180. 2x equals 45. Divide both sides by 2, and x equals 22.5. Okay, so I want for you to go to exercise 4.14 on page 238 and do numbers 2, 3, 4, and 5 for your homework. Now we're going to take a look at the other exercise that I want to do with you, and that is going to be exercise 4.15 on page 239. And this is about the angle between a tangent and the radius of a circle. So we are already familiar with this word radius. A line is tangent. A line is tangent if it touches the circle on only one point. Okay, so this line is tangent. This line is also tangent. Okay, so it intersects with only one point. So yeah, touch is not the appropriate word. A better word is that it intersects. It intersects the circle at only one point. Intersect. So when we do this, we can then create two triangles, and I'll just leave it as black. So if I take that tangent point, that tangential point, and I connect it to the center, then this gives me a right angle. And I ought to say actually is that is if the center line between these two tangent lines is also just an extension of my radius, just like that. So then if I connect that radius with that tangent point, that tells me that this is also a right angle. Okay, so let's take a look at some examples. So this is from exercise 4.15, number 1. So let's go ahead and let's do this one first. Okay, so well, in reality, this actually is not a tangent line because it intersects in two places, but that's just because my drawing isn't perfect on this because I don't have the right tools. So let's say that it intersects here at only one place, okay? So this line here is tangent to the circle, and here is that one point of intersection. One point of intersection. So what that tells me is that this angle here, where it intersects and also goes to the radius, that this is 90 degrees here. So here I know that 90 plus 55 plus x is going to equal 108. And so here x equals 35. X equals 35. It was a little bit of an easier example, so let's try one that's a little bit more difficult. So number 6 from exercise 4.15. Again, so I have this line. I'm really bad at this. I have this line, which is tangent. So this, we're going to say this point here is where it intersects with the circle. And so I've connected that line to my radius, and that is going to be a right angle. Okay, so that is a right angle where I connected it with my radius. So I know that if I add together 38 Actually, I don't know if I want that yet. Okay, so now that's the right angle. I can come up with this angle right here because I know that 90 plus 38 plus that question mark there is going to equal 180. That'd be 128. And so that question mark angle is going to be 52. Okay, now that I know that, I can decide that this angle here, I know plus the 52 is going to have to equal 180. So it is going to be 128 right here. Okay, I'm getting a little bit closer. And actually, because I know that this is my radius, and this is also my radius, that the length of these two sides is equal to one another. So I know that the angles are also going to be equal to one another here and here. So if I have 128 plus x or 2x, I know that it has to equal 180 degrees. Subtract 128 from both sides. Divide both sides by 2. And x equals 26. Okay, so your homework for exercise 4.15 are numbers 2, 3, 4, and 5. And something that I didn't talk about, but is really important for this, is that sometimes you'll have just these two lines you won't have in the middle, right? But also it's really important to know that if we're splitting that circle right down the middle, that this side and this side is going to be equivalent. So obviously this angle and this angle are equivalent. They're both our right triangles. This side and this side are equivalent. So that tells me that this angle and this angle are equivalent. And then same thing is that this angle here and this angle here are going to be equivalent, okay? So these are opposite reflective triangles, okay? That'll help you when you're looking for signs that are similar. That's all I've got. Have a good day. Please reach out to me if you need any help, okay?